science friends. This is the last day of this stoichiometry unit, and on Monday we'll be doing the study guide, and then Tuesday taking a test over stoichiometry. So let's go ahead and get wrapping this up. So today we're going to talk about percent yield. You did a little bit with percent yield in the activity that you did in the interactive Google slide on Wednesday. So if you remember in that activity, I gave you a small example of it with the ice cream cones. So I said you were supposed to be making ice cream cones for a party, and you had bought enough ingredients to be able to make, I don't remember the number I used exactly, 12 ice cream cones, let's say, okay? And so, but you knew there were only 10 guests at the party, and so you made all the ice cream cones. Theoretically, with the ingredients that you bought, you should have been able to make 12 cones, okay? But what you actually took to the party was 11 cones, okay? Because one of them got confiscated for yourself on the way to the party. And so that was kind of more like the actual yield. And sometimes this happens in chemical reactions too. We have an amount that we can expect that a chemical reaction should produce. You've been calculating this in your stoichiometry equations. This theoretical yield is sometimes called our expected value, okay? And then the actual yield is sometimes called our observed value. So you may see me or hear me use those terms interchangeably, and so just recognize them both ways. So the expected value is always calculated. You calculate this with your stoichiometry equations. Your actual value is always determined through experimentation. So you don't know how much you're actually going to get until you carry out the experiment to see. And then you can use your actual and your theoretical values to determine percent yield using this formula. Percent yield is actual over theoretical, and that'll give you a decimal. If you have a really good percent yield, it might be like 0.98 would be your decimal, and then you would multiply times 100% to get like 98%. If you have a really bad percent yield, then you would have a low number. So you should never have like less than 0. You should never have like a negative value for a percent yield. Sometimes, I'm not going to say you can never have more than what you're supposed to get, but that would indicate that your experiment went really wrong if you got a over 100% percent yield. So ideally, a good chemist would get, a percent yield somewhere in the 90%, and if they did a good job, okay? And in college, when you do these experiments, your percent yields are often tied to your grade. So they will tell you you're supposed to get this much, and you carry out the experiment, and if you get close to that much, you get an A. If you don't get close to that much, you don't get an A. And so sometimes that really does happen in college chem classes. So let's go ahead and do a practice problem with these. So I've got these practices, or I'm just going to give you one practice here together, and then I'm going to turn you loose to do one practice on your own, and then we can check it. So calcium carbonate, I want to say first I have written calcium carbonate incorrectly here. So make that change there and there in your notes. I'm not sure what got into me. Carbonate is CO3. Calcium carbonate is decomposed by heating as shown in the following equation. And so if you look at that equation, you should see that it's already balanced after we change that to a 3 there. So it says, what is the theoretical yield? So remember, that's something that we calculate. As we just said, we have to calculate the theoretical yield of CaO if 24.8 grams of CaCO3 is heated. So we're going to use our stoichiometry to calculate this, just as we have done for the past couple of days. So always are going to start with what they give us, 24.8 grams of CaCO3. And I'm trying to find the yield of CaO, okay? Now, it doesn't tell us if we need to calculate it in moles or grams. And so because this one is already given in grams, I'm going to calculate it in grams because all we need is a yield. You could convert this to moles and convert that to moles and get percent yield in moles, and that would work perfectly fine too. Generally, your percent yield is going to be in grams though, because that's how we can easily measure quantities in chemistry. Okay, so 24.8 grams of CaCO3, and I'm trying to get to grams of CaO. So what I have to do first, I want grams of CaCO3 on the bottom in 1 mole, okay? And I know in 1 mole there are, if I add up the molar mass, I think it's 100 grams of CaCO3 in 1 mole of CaCO3. Now I'm going to move this 1 mole down to the bottom, CaCO3. And so my mole to mole ratio here is 1 mole of CaCO3 per 1 mole of CaO, which is what I'm trying to find, okay? And then 1 mole of CaO is going to be 56 grams of CaO. Calcium is 40 and oxygen is 16, so that makes 56 grams, okay? So I'm going to cross these out just to make sure I've set up everything correctly. And it appears that I have. And so if I do this calculation, 24.8 times 56 divided by 100, I should get 13.888 grams of CaO. Okay, so that is my theoretical yield. Okay, now in the second part of the problem, it says, what is the percent yield if 13.1 grams is produced? Okay, so remember our formula is percent yield equals actual over theoretical. Okay, so this is what we actually produced, this 13.1. So I'm going to put it on the top. And then theoretically, what we should have produced was this 13.888. And then we'll multiply that by 100%. So if I do 13.1 divided by 13.888, then I get 0.943. And so if I move my decimal over 2 places, that gives me 94.3% yield. Okay, so that chemist did a pretty good job with that one. He didn't lose a lot of product in the process. 94.3% yield is a very good percent yield. Okay, so again, this formula is really important. We use this a lot in biology. You're going to be taking your test at home on Tuesday next week. And so you can have this formula, I assume that you'll probably have that available to you in front of you. But if you were taking this test in class, that is not a formula that I would provide. I would expect that you know that percent yield is observed or over expected, or actual over theoretical, however you choose to remember it, okay? So I have one for you to try on your own. So take just a moment and pause me here, okay? And work that problem, and then we'll come back and look at it together. All right, on this one, you should have got a 91.8% yield, okay? So we started with what they gave us when 84.8 grams of iron 3 oxide, okay? So we have 84.8 grams of iron 3 oxide reacts with an excess of carbon monoxide. That means that's your excess reactant, okay? It means you're not going to run out of carbon monoxide first. Iron oxide here would be the limiting reactant. 54.3 grams of iron is produced. So this is our actual. Sorry, my kids are screaming. What is the percent yield of this reaction? So we have to get from 84.8 grams of iron oxide to iron, okay? That's what it's asking us about. Iron is produced. So do the molar mass, okay? And then you're going to do the mole to mole ratio, which is a 2-to-1 ratio, and then the molar mass of iron. And I got 59.148 was the theoretical yield, okay? So I plugged this in here at the bottom for the theoretical yield, 59.148. For my actual yield, I plugged in the 54.3 from the equation, and so I was able to calculate 91.8% yield, okay? So again, that was a pretty good percent yield. The one thing that I'll advise you about, sometimes in the problems, this one gave you two numbers. And so you kind of have to look to see what number do I start with? What number am I working with here when we start our equation? Which one is our actual and which one do we need to try to do some type of conversion with? Okay. So your assignment for today, you don't have the paper in your binder, so it's digitally on Google Classroom. You can see the assignment, so I just want you to write out the answers on notebook paper and upload a copy of that. And I think that's all we've got for today. So if y'all have any questions, let me know, and if not, then you all have a great day.